Hello, folks. So, in this video, I wanted to talk about an interesting small problem that we recently noticed. So, let me start off by telling about the problem itself, like what we noticed and what we found out later. Like, what are the symptoms that we found out, and then how did we find the root cause and all that? Like, what are the basics that I found out? Because this was a problem that was faced by the team, and one of my colleagues was debugging this, and yeah, let's get started. So basically, what happened is this. Let me show it. So basically, there was basically the symptom that we first saw was that we have some tests running, automation tests running, right? Automation tests. So these automation tests were not running at some point. We got some alerts, but we missed the alerts for not running of no runs, right? But we missed the alert, but that's okay. Finally, the users, that is the developers, basically told us, the infrastructure team, because we maintain the infrastructure and we also maintain the infrastructure for the automation tests and the systems that trigger the automation tests. So the users, the developers, they told us that the automation is not running, and then we checked it out. So what happened was basically this. So basically our automation tests are run by just exactly one instance, as in like triggered by one instance. It is run in an appropriate environment. It's triggered by exactly one system, one pod specific, like it's a one pod specifically in Kubernetes, right? This pod actually has a cron running, right? It's a cron scheduler, so we run cron tab, cron d, and we use cron tab to configure it on. So we run cron. So there are like a list of commands to run in the. When you look at the cron tab configuration, you will see some schedules like star or whatever, like every hour, 30th minute, for example, 1:30, 2:30, 3:30, 4:30, and so on, from 1 p.m. to 9 p.m. all weekdays and all that, right? So that's how they've written it. And so they put the schedule in the cron format, and then they tell what is the script to use to trigger the automation run. So there is a script, and the args for that script is given. And basically this was not running. Basically what happened was, I can't recall exactly why this had an issue, but basically when we were looking at the logs of this pod, we could only see the logs of a different program that we were running in this pod, which is to ensure that the cron tab configuration is always up to date. So basically what our application, which is called updater, was doing was, it was pulling a file from a GitHub repo, which is a Git repo. So GitHub Git repo, it was pulling it, and then in that was the cron tab configuration, and then it used to update the cron with that. Okay, so the logs of this was shown here. What it used to do was, it used to run git pull again and again. Okay, and then it used to update things. So it used to run git pull every 60 seconds. So we noticed that this git pull was failing from the logs of the pod. Only that is what we noticed. It said fork, and I think it said resource unavailable, something like that. It's a Linux level error. So fork is the Linux system call, and it basically said that resource not available, something of that sort. So if you Google this error, you will realize that it basically means some resource is not available. For example, it can be process IDs, right? the number of processes, or it can also be, I think, I'm not sure though, it can be, I think, compute network storage, so it can be disk, it can be memory and all that. When you say memory, like when you say resource not available, so compute meaning CPU and all that. But here it was fork specifically, which is related to process forking to create a child process and all. So this was about process IDs. Basically in Linux, we could see that a lot of process IDs were there. How did we find out that this is related to processes and not any other resource? Was basically, so my colleague used AI and was checking what was the problem in the pod which had the problem. So basically, what we noticed was the AI found out that in this pod a lot of processes were there, zombie processes, right? So a lot of zombie processes were there, right? These processes, if you do ps aux, you'll notice that there are a lot of processes, and it will be written as defunct, right? And something about xim4, I can't recall what this was. I think this is about some storage or something like that. But defunct is to say, I think, zombie process. And you can also, I think, see the stat of the process which says Z, I think, which means zombie process. And there were a lot of these, by the way. So basically, we noticed later what was the problem. So this updater program that we were running to run git pull and everything was actually a Python code. And in this Python code, we made shell calls, right, to do git and all that. We weren't using any specific git library per se itself, at least previously. So what happened was we were running shell call inside Python. So when doing this shell call, we actually used a method, a module in Python called subprocess, and we used popen for it. I think it's called process open. Basically, when you do this, you open up you start a process. Ideally, if you use popen, you should also use wait to close or wait for the process to get over so that it gets garbage collected, right? GC. So if it is not cleaned up, it will become a zombie process apparently. At least that's what I read, and I need to try this out and also understand how can you create zombie processes simply to try it out in Linux using, say, C++ by doing fork and all that. So instead of using, like, say, Python directly, but instead directly use the system calls and understand how to create a zombie process by not cleaning up the child process and all. So how this happens exactly at a low level. So because of this, there were a lot of zombie processes. And so basically the idea was to apparently subprocess has one more thing called run, a method called run. And if you use that, it will open up the process and also close the process, like clean it up and everything, and, like, as in take care of the garbage collection. But if you use popen, you need to properly put wait, or you need to do something like, I think, with block or something, and accordingly it will take care of it. So basically, then we updated the code. There was already some updates to the code that we didn't deploy. So there we had used some Git library and all, I think. And finally we deployed the code, like, after fixing this thing, right? But the interesting thing was the build was failing, the Docker build. So since this is a pod, it's containers, it's Kubernetes, container orchestration and all, the Docker build was failing. So there was a lot of hacky stuff that was being done to fix this build, because basically what happened was, in our case, we actually do a Docker and Docker build. Basically we use Docker and build a Docker container inside Docker itself using AWS code build. And there are some limitations to this, like some limitations in our specific platform which I need to read about. But those prevent us from using, for example, say, base images, like, say, the latest Ubuntu. We always end up using an older Ubuntu. And in this case, there was some Debian usage, and we had to use an older Debian, for example, Bullseye, and that's working because we had errors like, for example, cannot allocate memory for some reason. I don't know. Cannot allocate memory, though we increased the build, what do you say, code build environment, the compute, like from 2 CPUs and 4 GB RAM to 4 CPUs and I think 8 GB RAM or 16 GB RAM and all. But still, it didn't work out. It said it was trying to do some, uncompress or decompress a compressed file and all, and it had some errors while trying to do that decompression. So, anyways, finally we fixed the Docker image build somehow after some modifications. We deployed it. We noticed that the cron is all running, no zombie processes and all. And but then we noticed that the tests are not getting triggered, basically. So then we started looking at the cron and AI. Basically, my colleague used AI, and it said that the cron tab configuration has an issue, where we basically mention what is the command to run, and the command to run is mentioned using a variable, and the variable is defined at the top of the cron tab configuration. So AI said that the variable was not defined properly. Basically, it said script, and it said script, and then it said what is the path of the script, etc something. There was a space here and here, and AI was like, this is the issue. You have to fix this, and this is not a variable if there is a space here. We checked the cron tab version, cron D version and all, in both the older and newer ones. It's the same, and this cron tab configuration has not changed. It was working in the older one. In the newer one also, the version is the same in the newer deployed pod. So I thought that this is not the problem. So I went ahead and checked this by actually running echo and then the variable name, which was script something, and then I put it into a dummy file, dummy.log, and this worked actually. I also put date like this, and then I also put the script together in one line and did it, and it worked with a schedule like every minute run it. So finally we noticed that the commands are getting called. It says that the command is $script something, and then the arguments were mentioned in the command. Basically what was going wrong was basically we need to understand now why the script is not running. We didn't run the script itself, that /etc whatever script was there. We didn't run it directly. So we should have done that first, manually triggered it to see what was the problem. Later I was just wondering, why is cron not able to give the output or the logs from this command run, right? So then I realized that the new pod where this was running, it was giving no MTA installed, which means no mail transfer agent installed, so discarding output. So it was discarding any output that the cron was running, the commands that the cron tab was running. So basically you could see in var syslog that var log syslog that the cron is running, but no logs of the commands that the cron was running, because it said no mail transfer agent available, so discarding output. So basically it requires a mail transfer agent, like for example postfix or something, to actually send you the logs of that. So for this error or for this warning, no MTA agent, no mail transfer agent, the suggestion was to either put the commands output into a file and also do redirection of I think all the output to the std standard output, something like this of sorts, redirection script, right? So basically we didn't do this because we have to change the whole cron tab configuration, but though we can, I was like existing case we are able to see the logs in /var/mail/mail. So I thought we can just check it there. It's just that we have to install postfix. In this case, postfix was not installed in the newer one. In the older one, it was there, and the logs were coming. So what I did was I went ahead and used redirection into a dummy log file, and it showed the logs. It showed that the curl command was not available. This script that we were running uses curl to trigger the automation at some server. So this since curl was not available, it was not able to trigger the automation. So then we installed curl and it's working fine. And the cron tab configuration, we didn't make any change. Instead, we just are going to ensure that postfix is installed. The only problem is currently in the pod logs, updater logs come up, but the crons logs, that is the var logs syslog or the var mail doesn't come up. Ideally, the crons logs should come up, right? And then the commands that the cron runs should come up, and also updater. All of these logs should come up in the pod logs. Maybe we can run these as separate containers inside the pod and ensure that run the updater and the cron in separate pods, and ensure that the cron and the cron command logs come up in that one pod, and the updater command logs come up in the other pod, so that we have all the logs in the console. And then we have log system, like in our case it's Loki, to actually push all the logs to Loki. Or else what happens is var log syslog and var mail becomes bigger and bigger, and at some point we have an issue where we have a disk pressure and all that. Pods, basically the ephemeral storage, will have some limits, or the worker node where the pod is running will have some limits, causing these problems. And the other thing is the process IDs. There is a limit on how many process IDs that Linux can have. It is some 2 power some big value actually, which is some 4 million something, I think. The thing is, this problem was always there before and now also recently. But how we noticed this is a problem, what happened, why was the resource unavailable, why was it coming up now but not long back, was because we were running on spot instances before, the worker nodes in Kubernetes. And before this 4 million process IDs could be exhausted, when we were around 1 million or 2 million itself, the spot instance got interrupted, and hence a new pod came up, and hence new processes came up, and again the process ID count got reset to 0. Recently what happened was we actually upgraded our Amazon Linux from Amazon Linux 2 to Amazon Linux 3, which is Amazon Linux 2023, right? So this, what happens is, in Amazon Linux 2023, what they do is the worker node checks the number of pods that are there in the worker node, and checks the total number of process IDs that it has, which is 4 million, and it divides 4 million into the number of pods, and accordingly gives that much amount of process IDs limit to each and every pod. So now the number of process IDs, max process IDs count decreased for each and every pod after we released this, upgraded our Amazon Linux version, and hence now it was hitting this limit of process IDs very quickly, which was some 32,000 or 320k. So right, so 32,000 or 320k, one of those, 32k or 320k, and it hit it, and hence we had this problem. So yeah, that's all I had for this video, talking about this problem and the various things that happened, and how we were testing things out, and what all interesting things AI thought of or found out, which was real or was not real. For example, the process ID issue, it did find it was correct, but why was it a problem only this time? I mean, my colleague found out after a lot of probing and prodding the AI, and also on his own. So yeah, I mean, interesting problems. So yeah, that's all I had for this video. I'll see you in the next one. Bye bye.